Hello and welcome. In this video, we are going to do a quick, well, not really quick. We're going to do an example of proof by induction that we started in class, and even though you're not required to prove this in class, there is one similar to the homework that's going to be like this. So I want to go ahead and do the proof for you. In class, what we did was we set up for n equals 1, n equals k, and n equals k plus 1, but then we stopped. So let me just finish this one off. So watch this. Use it as a template for the one that you do need to turn in for your homework on 9.3. All right, so the first thing you want to do is prove for all natural numbers n that 7 to the n minus 4 to the n is divisible by 3. Say that you need to state what it is that you want to prove. The next step, step 2, is you let n equal 1. And now this is the part that we did in class. So let n equals 1, so then n, and then wherever we've seen n before, here, wherever we've seen n here, we're going to replace it with 1. So we put in 1 for n, so we have 7 to the 1 minus minus 4 to the 1, which is 7 minus 4, in other words, 3. And clearly, 3 is divisible by 3. So since 3 is divisible by 3, this holds for n equals 1. The step 3 here is we assume that for n equals k, 7 to the k minus 4 to the k is divisible by 3, and this is going to be true for some value of k. That is that since we have to show that we assume it's going to be divisible by 3, we're going to let 7 to the k minus 4 to the k equals 3 times some m, where m is just a number. It's just a natural number, okay? The next part, part 4, is we're going to do, and this is the part we did in class, is let n equal k plus 1. That is that we have 7 to the k plus 1 minus 4 to the k plus 1. Now all of this, except for the words, we didn't complete all the words on the proof in class, but we did set it up for n equals 1, n equals k, and n equals k plus 1. The next part's the new part. So let's go ahead and go through the new part. All right, step by step. All right, so what I'm doing here on this step is I am using the rules of exponents that says if I have a raised to the m plus n, then this is just a to the m times a to the n. So in other words, I am taking the 7 to the k plus 1, and also with a 4, and I'm going to rewrite it as 7 to the k multiplied by 7 to the 1. And I did the same thing for the 4. So that's all I did in that step. Okay? Now, this part is I know that I can write 7 any way I want. I can write 7 as 7 plus 0. I can write it as 7 is equal to 5 plus 2, 3 plus 4. I want to use 6 plus 1. I'm going to do the same thing with 4. 4 is the same thing as 3 plus 1, 2 plus 2, 4 plus 0. Now the reason I'm choosing this, and you're thinking, why am I choosing this? The reason I'm choosing this is because I want to have this number and this number that are both divisible by 3. All right? So on this next step here, all I did was write the 7, which is this 7, right here. I rewrote 7 as 6 plus 1. I wrote this 4 as 3 plus 4. On the next step, what I did was I distributed the 7k onto the 6. In other words, I multiplied them. I distributed the 7k onto the 1. In other words, I multiply them. And that's where this part comes from. So I have 7 to the k times 6 plus 7 to the k times 1. I'm going to distribute a negative 4k on the 3 and negative 4k on that 1. So I end up with this. I have a negative 4k times 3 minus a negative 4k times 1. For this step right here, is I just rewrote it from here to here, where I have my 7 to the k plus times 6 is here and here, and then I took this portion right here and I just moved it right here. So I wrote 7 to the k times 6 minus 7 to the k times 3. All right? That means this term just gets moved back a little bit, and this term is still at the very end. Now, once I have done that, okay, I know from my third step that that part, because I assumed it was true for k, that part itself must be divisible by 3, and in fact what we said, it was equal to 3 times m. All right? When I take a look at this step, all I did was I replaced my 7 to the k minus 4 to the k because of this. Because I said it was true for some k and for some n, that 7 to the k minus 4 to the k is equal to 3m. All right? Now, for this step from here to here, all I did was I said, there I have a 6 and I have a 3. So out of these two terms, again, out of these two terms, there was a 3 that was in common, because 3 would go into this 6 and a 3 will go into this 3. So I factored that 3 out, leaving me a 2 and a 1. I still have 7k and I still have 4k. This 3m is just coming along for the ride. So all I've done, again, is I factored out a 3 out of the first two terms, and I've brought down that plus 3m because I'm not ready to do anything with it. Now, to go from this step to this step, here is one term, and here is one term. Out of those two terms, I factored off this 3 from here and here, so that's where that 3 comes from. What's left over is 2 to the k, or 2 times 7 to the k, minus 1 times 4 to the k, and then the plus m. Right here, what we have is some number is a multiple, or in other words, divisible by 3. So since 3 times that number is divisible by 3, then 7 to the n minus 4 to the n is divisible by 3, and it holds for k plus 1, assuming it's true for k, for n equals k. All right, now let's go to the very bottom here. And so by the principle of mathematical induction, we have that 7 to the n minus 4 to the n is divisible by 3, will be true for all natural numbers n. So on the homework, give it a go, and then if you have questions, send me your questions and we will go over it in class, or I'll just send you an email, or at some point, maybe on Friday, we can spend time after class working on it after noon on Friday.